In Philadelphia, the number of hours of daylight on day t, where t is the number of days after January 1st, is modeled by this function. Which days of the year have about 10 hours of daylight? So this is giving me some like complicated information. And so I want to actually model this and draw this out before I start thinking about what it's asking me, because I just need to understand like what is the situation. So I'm going to start by making a sketch of this. So this is a sine function. So I'm just going to make over here, I'm going to make a smaller version. I know the sine function looks like that. That's the shape of it. And it looks like this says 2 pi over 365. It looks like it's trying to turn the period instead of 2 pi into 365, which kind of makes sense because it's about days of the year. So it looks like the period is going to start on January 1st and then end December 31st. Okay. It also looks like it's shifted up a little bit, and it starts over here. Negative 80 is where it starts, and it's shifted up 12. So it's gonna be like, I don't know, something like that. I did not do the greatest job of drawing this, but one thing I can notice is that at most of these points, there are going to be two different points, 2 different days that have the same amount of sunlight. Okay, so at these, sometimes they only have a unique amount of sunlight. I'm sorry, I didn't draw this great. I'm going to shift December 31st over there so you can see that there's a lot of days with matching amounts of sunlight. So day X and day Y both have the same amount of sunlight. And this is hours of sunlight. Okay, so we have this function. Now let's see what it's asking. Which days of the year? So we're going to be looking for, so this is t right here. This is days of the year. We're going to be looking at certain values of t that would have 10 hours of sunlight. Let's say this is 10 hours. So in this function, it says the function gives the number of hours of daylight. So over here, the value of the function should be 10. And then we're going to solve for t. So far this looks pretty good because we know how to solve equations for a single variable. So I'm just rewriting this 365 t minus 80. Okay, so we're just literally solving for t. So let's just, basically get t alone as much as possible. So minus 12, negative 2 equals 2.83 sine 2 pi over 365 t minus 80. Okay, and now I'm going to, we're just going to keep going. We're going to do divide by 2.83. Okay, so now we have negative 2 over 2.83 equals sine 2 pi over 365 t minus 80. All right, and so then if I take the inverse sine of this, of 2.83 is equal to 2 pi over 365 t minus 80. Again, we're just like, solving for t, but now we're going to stop. once we find the angle. So we're going to do this. We're going to find the inverse sine. So I'm using a calculator, and I get negative 0.785 when I took the sine inverse. So this is equal to 2 pi over 365 t minus 80. So you can think of this as like the angle, because this is the inverse sine. And remember, this is going to have another one that has the same output value. So let's just look at a unit circle real fast. So I'm going to draw it over here. Say I have some angle theta that has a certain y value. So its sine is whatever. It has a certain y value. And then there is going to be another angle this angle is going to have the same exact sine, right? You can see these both hit the, if the unit circle is going around, which I'm terrible at drawing unit circles, but they will both intersect the unit circle in a way that gives us the same y value. Or if we look over here, maybe they go down. We've got, say, this guy. It has this angle theta. Then we could have another guy that has this angle, and they're both going to have the same y value, okay? So there's two different sines that have the same y value, just like we saw here. Sorry, two different angles that have the same sine. Two different angles that are going to give us the same output value. Okay. So, how would we find this? I'm going to draw it one more time because I was a little messy. So, doing the first example, if this is theta, what is this other angle? Well, if we started at pi and went backwards, theta, we're going to get that matching angle. So another way to say this is sine of theta, the output of that is the same as if you did sine of pi minus, because we're going backwards, theta. Or we could say, we could look, I'm just going to draw it again because it always gets so messy when I try to do it multiple on the same one. If we're going to look at this downward one, even if it's a long angle, we're going to see it still works. Sine of theta, if we do this whole big angle, well, the matching one with the equivalent y value, with the equivalent sine, that's the same as if we started at 0 and went forwards. If we started at pi and went backwards, you can see I made that same loop. So this is still saying sine of theta equals sine pi minus theta. Okay, these two angles are going to give the same sine value, the same output. Okay, so this is our theta. So we also need, we have this, and so this equation is true, and we have another equation that's true, which is, because is pi minus theta. So let's do this. So pi minus negative 0.785 equals 2 pi over 365 t minus 80. All right. And then at this point, we're just going to go ahead and solve it. So I used a calculator when I did this before, and at this point it's just algebra. And I got t equals 34.4, and over here I got t equals 308.1. So let's remind ourselves, what is t? T is the number of days after January 1st. So if it's a day, it's asking which days of the year. We don't want fractions. So we're going to round. So t equals 34 and 308. So the 34th and the 308th day have 10 hours of sunlight. So for these equations, basically, you're going to solve it regularly until you get that angle, right? That x value, because you know there's going to be two different angles that are going to both give this. So you want to set both of those angles equal to that y value, that output. And then you just solve it from there. And this was only asking for 1 year. If it had asked for more than that, like for many years, you would add plus 2 pi k, right? Like you would add plus the period times integers here, and then you would do the algebra. So just sometimes I get confused about where to add that in, but you do it right at this step. All right, hopefully that clears things up.